Oh, hi there. Today we are going to learn about the types of circuits. This goes through section 13.1 of your textbook, and we will identify characteristics of parallel and series circuits. And as we go through the video, feel free to pause and rewind, watch as many times as you need to, and copy down the notes as we go. Okay, so here we go. Here we have an example of a series circuit. So in a series circuit, the electrons only flow in one path. And remember, the wires are the conductors that provide the path for the electrons to flow. If there was a break in the circuit, then none of the loads would work. So if this switch were to be opened, right, or one of the light bulbs were to burn out, then everything in this circuit would stop working, because the circuit would then be incomplete because electrons would not be able to flow past that point. These diagrams are taken from page 552 in your textbook. Now, if we were in class, we would be able to build a circuit like this. This week we are going to be doing an online lab. Well, you'll have the opportunity to build some circuits virtually. In your textbook, you will see a diagram like this. Please notice that when drawing diagrams by hand, that we use a ruler. All of the corners are right angles. All right, and we label the terminals of our cell. The short line is the negative terminal, and the longer line is the positive terminal. In this example, this is a one-cell battery. Right, our switch here is closed, so our lights would all be on and working. Series circuits are best used in simple devices because there is only one path. If you want to control loads separately, you would not be able to do so with a series circuit. So simple devices such as a flashlight in your home would be wired with a series circuit. So here we have a parallel circuit. You'll notice right away from the diagram that there's some differences between this and the series circuit. So in a parallel circuit, there is more than one path for the electrons to follow. So we can notice that we have our first path here for our first light bulb, and then we have our second path down here for our second light bulb. So because there are two separate paths for these light bulbs, then each of these loads can be controlled independently. So you could have a switch on this path here to control our second light bulb. You could have a switch on our first path that would only control the first light bulb. And if you wanted to shut the entire pathway down, you can put a switch on the main branch. So this part of the circuit here is considered the main branch, and it will shut down the entire circuit. So in your home is wired in parallel, and you may have in a closet or in your basement a fuse box or a circuit breaker panel, and there'll be one master circuit breaker for your entire house, so you can shut all the electricity down in your home if you were having electrical work done, and that is cutting off the power right at the source. So here's an example of a parallel circuit. Again, if you were to build one at home, notice that our alligator leads would be attached to the metal connections because we need those conductors to be connected that allow the electrons to flow. Right? The electrons will leave from the negative terminal of the battery, flow through the connecting wires, and return to the positive side. So because this is a parallel circuit, this light bulb here is on its own path. All right. In your textbook, you may see the parallel circuits drawn like this. All right. So notice that there is one switch. Now, do you think the switch would control one lamp or both lamps? That's right. It would control both lamps because it's on the main branch. Where would you put a switch if you wanted to control each light bulb separately? That's right. You would want to put the switches on the individual branches in order to control the bulbs separately. All right, so here we have 5 different circuits. So take a moment to identify which ones are series and which ones are parallel. You can pause the video if you need to. All right, and now we can check out the answers. All right, so numbers 1 and 4 are series circuits, and 2, 3, and 5 are parallel because they have more than one path. All right, so now we have an opportunity to practice. So pause the video and using a pencil and a ruler on a piece of paper, draw a series circuit with one cell, 2 lights, and a closed switch. And once you have your circuit drawn, identify how many paths there are for electrons to flow, and then problem solve if the first light bulb were to burn out, what would happen to the second light. So pause the video, draw your diagrams, and then move on. Alrighty, so here we are going to start with our branch here. Oops. Alright, so we need one cell, so we've got a big and a little line, and we'll label our terminals, and then we will leave a space for the light bulb, leave a space for the light bulb, and then we can close this circuit up. All right, so we'll add our close switch and our light bulbs. So if we take a look at our circuit, all right, how many paths are there for electrons to flow? So there is one path for electrons to flow. Remember, they will come out of our negative terminal, flow through the circuit, and return to the positive. All right, and if this first bulb were to burn out, what would happen to the second bulb? Well, it would also be off, because as soon as there is a break in the path, then we can say that the circuit is incomplete and the electrons cannot flow past that point. So electrons would not be able to get past this light bulb, meaning the second bulb would also be off. All right, so now we have another opportunity to practice. So this time we are going to draw a circuit that contains a 2-cell battery, 2 lights that are in parallel, and we need a switch to control each light independently. So pause the video and practice drawing this diagram, and then we are going to take a look at the number of paths in the next slide. So take a moment and draw your diagram. All right, so let's check our work. So we are going to start here, right? And we will put a 2-cell battery, which means we need a big and a little, and a big and a little. So we've got our positive and our negative terminals. Now we need 2 lights that are in parallel. So let me draw this here, right? So we will have our first branch, leave a little gap. And then we have our second branch. Again, leave a gap to draw the light bulb in. And then on this side, we can close up our circuit. All right. I'll get my ruler out of the way here. So we'll draw in these light bulbs. Now, if we want to control each light independently, then we need our switches to be on the side branches. So each of these will allow us to control light bulbs separately. All right, so if we had put our switch here on the main branch, then this will shut down the entire circuit, whereas when we put our switches on a side branch, then they will control the lights independently. All right, so how many paths are there for these electrons to flow? So here we have 2 paths, right? So electrons can either choose to go through this first branch, or they'll come out of the battery and continue down and go to the second branch. All right, so if we were to open this particular switch, all right, so if we erase this here and instead we had an open switch, all right, then what would happen in this example? Well, if we open this switch, our second light will go out because the electrons cannot flow past this point. However, this light bulb would still be on because our first path is still complete. Well, that brings us to the end of this lesson. So hopefully you understand series and parallel circuits, and at this point you can continue on through the weekly planner. So moving on to some practice, solving problems related to series and parallel circuits and some textbook work, and you can find both of those posted online. Bye for now.